Assalamu alaikum students and welcome to another lecture of Slate. This is Khawaja Yasin. Let's study chemistry. We have had made various videos regarding moles and this will be the last one for O-level students but not for the A-level students because for A-level students we will be practicing more questions from the A-levels past papers. But let's talk about the most important and one of the most confusing topics of moles, and that is the limiting and excess reagents. So what is the limiting reagent? What is an excess reagent? Limiting reagent. Now, as the name goes, that a limiting reagent or a reactant, you can also call it a reactant. It's one of the reactants. The reagent that limits the amount of product being formed. But how? The reagent that limits the amount of product being formed, but that is why that's because it is lesser than its stoichiometric value. Metric amount, you can say. So the amount of this reagent is lesser stoichiometrically. So you can just say the reagent that is lesser in quantity or amount or concentration. Or have moles lesser than its stoichiometric value. So this definition is a very basic one. It's not a very justified one when we talk about understanding of the concept. So limiting reagent, let's talk about a very basic reaction. This is, let's burn methane in air. This is combustion. We get carbon dioxide and water. So let's balance the equation. 1 mole of carbon, 1 mole of carbon dioxide, 4 moles of hydrogen, so 2 moles of water, and we get 2 moles of oxygen. So students, here we see that 1 mole of methane is burning in 2 moles of oxygen. But when we burn something, when we burn gas, when we burn methane in air, the air is always in excess. Obviously, unless it's a limited combustion, it's an incomplete combustion, the air is in excess. So what do we mean by excess? In real, we need just 2 moles of oxygen, but we will be provided by, let's say, 7 moles of oxygen. So oxygen provided was in excess. 7 moles were there, but although out of those 7 moles, only 2 moles of oxygen were retained or used by us because we needed 2 moles as per the stoichiometric calculations, as per the balanced chemical equation. So the 5, they went towards the product side and we call it product mixture. The 5 moles went towards the product side and the 2 moles were used. But let's see, oxygen was already in excess. So the one in excess does not limits the amount of product being formed because the product will be dependent on the limiting one. Obviously, if I have a lesser amount of something, only that will make my product. My product will be dependent on the one which is lesser in amount, not the one which is more in amount. For instance, I have a glass of water, I have a glass of sugar. We know that the sugar can be added to an extent. I cannot add the whole glass of sugar in water. So the solution that is being made, there will be only a limited quantity of sugar being added and the rest is excess. So what is limiting the amount of solution? That's the amount of water, because water should have been more to dissolve all the sugar. But that water was actually the limiting reagent and limiting reactant, and that limited the amount of product or the solution being made. So the ample amount of sugar was useless to us because we needed a particular amount of sugar, a particular amount of that reactant. So the excess reactant does not determine the amount of the product. It is the limiting one. And the excess, when we talk about gases, since all of these are gases, we will just use 2 moles of oxygen here, and the rest 5 moles will go towards the product side because the reaction is enclosed. And this will give the altogether volume of the product mixture, including those 5 moles of oxygen. Now, there are various types of questions being asked regarding excess and limiting one. How to calculate them? How to find out which one is an excess, which one is a limiting? Because this is a normal example. We know for sure that oxygen is mostly in excess. But how do we calculate that in a question? We use molar ratio. Here, we will have to calculate the moles of both the entities. We are provided with the values here and here. We calculate the moles and we compare the moles under molar ratio. Let's do a question. A very basic. This is from the May-June 2023 exam, P2. So, the question states, the question is about the preparation of salts. Okay, that's the other part of the question. Zinc nitrate is a soluble salt. It is prepared by reaction of an insoluble carbonate with dilute acid. The equation for the reaction is zinc carbonate. 1 mole of zinc carbonate reacts with 2 moles of HNO3, which is nitric acid, and that gives us 1 mole of zinc nitrate, 1 mole of water, 1 mole of carbon dioxide. Perfect. A sample of 4.5 gram of zinc carbonate is added to 50 centimeter cube of 1.3 mole per dm cube nitric acid. So our two reactants are zinc carbonate and nitric acid. Now we have to calculate the moles of both of them. Since we have been given the atomic mass, the mass of zinc carbonate, we will use mass over MR formula for the moles calculation. So N equals to mass over MR. The mass is 4.5. Let's calculate the MR of zinc. Zinc is 65, carbon is 12, 16 into 3 is 48. So that makes it 60, 60, 125. So 4.5 will be divided by 125. Let's see what's the answer. What's the answer for this calculation? So 4.5 divided by 125, that is 0.036 moles. So they have asked us, show by calculation that zinc carbonate is in excess. The examiner was very kind this year that they already told you that zinc carbonate is in excess, but we just have to prove it. So these are the moles of zinc carbonate. Now let's talk about the moles of HNO3. We have the volume, we have the concentration. So N equals to C into V. Concentration is 1.3 moles. Volume is 50 divided by 1000 as it's in centimeter cube. So let's calculate the moles. The answer is 0.065 moles. Now students, we're going to make a molar ratio and compare the two values. Which values? Zinc carbonate ratio HNO3. First, we'll use the moles from the equation. Zinc has 1 moles. HNO3 has 2 moles. Let's take this value. So if we have 0.065 moles of HNO3, we do the molar ratio, cross multiplication, and 0.065 divided by 2, and that would give us 0.0325. So as per the stoichiometric calculations, the required mole of zinc carbonate are 0.0325, but we have 0.036 moles. Therefore, zinc carbonate is in excess. That is how you calculate that the stoichiometric moles of zinc carbonate are 0.0325, but the value that is given to you, that is 0.036 moles. So the given moles are in excess. Let's say they ask you to prove that HNO3 is a limiting reagent. So zinc carbonate ratio nitric acid 1:2. We have the moles of zinc, which is 0.036. We cross multiply the value becomes 0.072. So HNO3 should have 0.072 moles, but we only have 0.065 moles of uh, nitric acid. And that proves that the moles of nitric acid that have been given to us that are lesser than the stoichiometric calculation. So that makes nitric acid the limiting one. So I hope this is clear to you, but let's solve more questions regarding this concept. Because in this video, we will also be talking about the volume-volume ratio as well. Normally, in this question, what did we do? We had the mass molar ratio, and here we have the concentration mole ratio, and the volume as well. But this is different when we talk about gases. We will discuss that later. Let's do another question. This is from an IGCSE exam, because I will be discussing both IGCSE and O-level questions so that your concepts are clear in either of the ways. So 20 centimeter cube of sulfuric acid, and the concentration is given to us 0.03 mole per dm cube, was added to 40 centimeter cube of sodium hydroxide. And the concentration is given. So let's calculate the moles of both of them. So how many moles of H2SO4, which is sulfuric acid, were added? So we have the volume, we have the concentration. So N equals to C into V. So added moles are 20 divided by 1000 multiplied by 0.3. So let's calculate it. So the answer is 0.006 moles. How many moles of NaOH were used? First, let's calculate the moles of NaOH that were provided to us. So here again, N equals to C into V. So 40 into 20, 0.02. So that makes it 0.008 moles. These were the moles of NaOH which were given to us. They've asked about the moles being used. So students, here we need to first see which one is the limiting reactant, which one is the excess reactant. Again, that's the next question. Which reagent is in excess? Give a reason of your choice. So we have 2:1 moles between NaOH and H2SO4. So NaOH has 2 moles, H2SO4 has just 1 mole. And the given moles are, we have 0.06 moles of H2SO4, and NaOH moles becomes a question mark here. So we do the cross multiplication, and as per this calculation, the moles of NaOH should be 0.0012 moles. So that should have been the moles of NaOH. But how many moles of NaOH do we have? 0.008. So that makes NaOH our limiting reagent. And that is why H2SO4 is in excess. Because we should have had more moles of H2SO4. That's why it's in excess. Let's see how NaOH is limiting or H2SO4 is in excess. So let's do a calculation again just to confirm our results. So we have 2:1 and the moles of NaOH were 0.08 and question mark. So that makes it 0.008 divided by 2. So the moles of moles of H2SO4 should have been 0.004, but we had 0.006 moles of sulfuric acid. So that proves reagent in excess is H2SO4. Why? Because as per the stoichiometric calculation, Sulfuric acid should have zero point 0.00 moles, 4 moles, but we were provided with 0.006 moles, and that's why it's an excess. So next question is a very different one. Is the pH of the final mixture less than 7, equal to 7, or more than 7? So this is the neutralization reaction. Acid, sorry, alkali plus acid. And we know that the product form is neutral. But product form is neutral when we have equal stoichiometric quantities of both. But in this question, we had excess of H2SO4. So if the value of acid is in excess, so at the end, as I told you there, that the excess reagent moves to the product side because it's not being used. So your product has some acid in it. So if there is acid present in the product side, the pH is less than 7. Now moving on to the last concept, last question, which will have the same limiting and excess concept, but especially an added concept here regarding the volume of gases. Students, whenever we have to make a molar ratio, look at these questions. What did we do? We converted the mass into moles. We converted the volume of solution and the concentration into moles, and then we make a molar ratio. So for molar ratio, we always convert our values to moles. But that is not happening in the case of gaseous reactants and products. Why? This is a funny thing. Then we'll solve this question. That if we have a volume of gas, we will initially convert into moles by dividing it by 24 decimeter cube or 24,000 centimeter cube. We get the moles, and then we make a molar ratio. And from the molar ratio, we get the moles of the unknown. And what do we do with that unknown moles? We further multiply that unknown moles with 24 decimeter cube to change it to volume again. So here 24 is a constant value. In the case of MR, everything has a different MR or a molecular mass. So we cannot compare the masses of two. We have to convert them to moles. In the case of concentration and volume, concentration can be different than the volume, and volume can be different in different solutions. But in the case of gases, all gases, and that is the Avogadro's law, that 1 mole of any gas will have 24 decimeter cube. So here we'll see that how, since we have to divide and then multiply by 24 decimeter cube, we will skip this step. We will just make a direct volume ratio. Let's see this question. 10 centimeter cube of propane is burned in 70 centimeter cube of oxygen in a closed container. Why closed container? So that your products don't leave. And the mixture, at the end of the mixture, the volume is fixed. What is the total volume present? Volume of gas present after the reaction. So after the reaction, we know that if there is an excess, the excess also stays. As I said, after the reaction, the excess, but only the part that has not been used, that will stay. So let's see. We have, let's write the equation here. So students, this is the equation. What do we have? We have the volume of propane, which is 10 centimeter cube. And we have the volume here, which is 70 centimeter cube. So if I convert this value to moles, I'll divide this by 24. I will divide this by 24,000 because it's in centimeter cube. But since we are dividing both of them, we don't need to do that. We will just compare the two values. So let's say we will make a molar ratio to first calculate which is the excess and which is the limiting. I know you can see that apparently it looks like that oxygen is in excess because 10 and 70, but that's not always the case. It can be opposite as well. We'll do an example that way. What it looks like, it's always not the same way. So we have 1 mole of propane, that's the equation, and we have 5 moles of oxygen. So if we have 10 centimeter cube of this, we'll need to have 50 centimeter cube of oxygen. But we have 70 centimeter cube. So we know that the amount needed, the volume of oxygen needed is 50 centimeter cube. So 70 is an excess. So only 50 centimeter cube is used and 20 centimeter cube is passed on as an excess. Now, in the question, they have asked us about the total volume of gases present after the reaction. So since they're talking about gases, this water is not a part of it. Let's exclude water here. So if we have C3H8 ratio carbon dioxide, 1:3, if we have 10 centimeter cube of propane, we'll have 30 centimeter cube of carbon dioxide. So that is where I tell you that we will directly do the volume ratio. If you want to try, you can convert these values to moles. There is mole of propane, mole of oxygen. Then you do moles of carbon dioxide. Then you multiply that with 24,000 centimeter cube. That's a long process. You are allowed only in the cases of the volume of gases to just make the direct volume ratio. When volume of gases. So carbon dioxide has 30 centimeter cube as the volume. So let's look at the options: 30 centimeter cube, 50 centimeter cube, 70 centimeter cube, 90 centimeter cube. So students, after the reaction ends, do not forget that 20 centimeter cube of oxygen was still in excess and that passed on to this point. So the reaction mixture has a total of 50 centimeter cube. So 50 is the answer. So my students, I hope this video was useful to you. If not, we will still be using more examples from the past papers. We will be solving more questions for you guys so that you understand moles. So thank you so much for being here with me. Allah Hafiz.